Hello friends, welcome to my channel. This is quick review for strength of material part 4. Elastic constant. First is E, Young's modulus, or E equal to modulus of elasticity. Modulus of elasticity is longitudinal stress divided by longitudinal strain, or linear stress by linear strain. Then G equal to modulus of rigidity or shear modulus. It's shear stress by shear strain. Then bulk modulus K. Volumetric stress by volumetric strain. Then K is bulk modulus. It's volumetric stress by volumetric strain or direct stress by volumetric strain. Then mu equal to Poisson's ratio. Sometimes in question they are writing mu as 1 by m also. So both you remember, 1 by m term and mu term. And Poisson's ratio is lateral strain divided by linear strain. Value of mu is lies between -1 to 1 by 2 or 0.05. And for most materials, mu value is greater than 0, less than 0.5 or 1 by 2. For some composite materials, composites or composite material, mu value is negative. And for naval foam, example, naval foam, mu is negative. Then cork, CORK, mu is 0. Then for rubber, mu value is 0.5. Relation between E, G, K and mu. This is very important in solving problems. Theory also directly this relation sometimes they are asking. E equal to 3k into 1 minus 2 mu. This is relation between E, K and mu. E equal to 2g into 1 plus mu. This is the relation between E, G and mu. E equal to 9 kg divided by 3k plus g. Then mu equal to 3k minus 2j divided by 6k plus 2g. Material and number of independent elastic constant required. Any material model, there is a relationship between stress and strains, linear relationship between 6 stress component and 6 stress component and 6 strain components. So for general material, 36, 6 into 6, 36 elastic constants are required. And for anisotropic material, number of independent elastic constants are 21. And for orthotropic material, it's 9. Number of independent elastic constants are 9. And for homogeneous and isotropic material, it's 2. Number of independent elastic constants are 2. This question was homogeneous and isotropic material. This question was asked in GATE also. So all four are important. One more thing is important here. For orthotropic material, example is wood. This is very important for public sector examination and IAS examination. Next is strain energy. Strain energy, the ability of material to absorb energy when it is strained. Half P into delta or half T into theta. T is applied torque and theta is angle of twist due to applied torque. P is applied load and delta is elongation due to applied load. Then resilience. Resilience is the ability of a material to absorb energy in the elastic region when it is strained. Resilience equal to area under P versus delta curve. It's equal to half P into delta. Then proof resilience. Proof resilience, the maximum energy absorbing capacity of a material in the elastic region. Its area under P versus delta diagram up to elastic limit. Its value is half load up to elastic limit multiplied with elongation up to elastic limit. Its maximum energy capacity of a material up to elastic region. And in stress versus strain diagram, this area, this is strain energy density. Strain energy density. And for resilience, up to yield point. Or elastic limit, up to elastic limit, modulus of resilience. For modulus of resilience, this area is up to elastic limit. Then modulus of toughness. Complete area. Stress versus strain diagram. Complete area is called as modulus of toughness. Resilience and toughness, these are two important properties for a material of a component which is subjected to impact loading. The machine components which are subjected to elastic deformation due to impact load should be designed based on resilience. So desired material should have higher resilience to resist impact loads. For strain energy, sometimes they are asking problems based on strain energy. You will use this formula. This one In different video I will explain this one. You just remember this one. mx square by 2ei into dx, or half p into delta. Both formula you have to use. Thank you friends. Thank you for watching my video. Thank you.